Good afternoon, dear viewers and followers. Glad to know you are following us on this YouTube channel. If you remember in our first video that we posted, we said we are committed to making mathematics easy and simple. We are committed to making mathematics loved by all. And if you have been following the tutorial so far, you will see that our solutions are simplified as possible, such that no step is being omitted. We choose to always follow this route so that everything in mathematics can be made known and can be opened in our tutorials. Thank you very much. In our last video, we talked about exponential function. We were able to explain the fact that exponential function is when an index is raised to the power of unknown, when a number is raised to the power of unknown, and it is required of us to calculate the value of that unknown. We saw some examples, and today we will be going through some tougher examples. Before us are some of the exponential questions that were extracted from the SSC past questions. So let's quickly see the solutions for them. Number 1, 25 raised to the power x minus 5 raised to the power x minus 20 is equal to 0. So when you have questions like this, the very first thing, as you still remember, is to simplify 25 raised to the power x, and of course you know that would be 5 raised to the power 2 times x minus 5 raised to the power x minus 20 equal to 0. This is the same thing as saying 5 raised to the power x all into 2. You still remember the law of product index law. So when this, this is taken as 2 times x to give us 2x. So this is 5 raised to the power x minus 20 equal to 0. So let 5 raised to the power x equal to y. That is, anywhere we see 5 raised to the power x, we slot in y. So we have y squared minus y minus 20 equal to 0. This is an example of quadratic equation. So if we remember in our last video, we talked about there are some questions like this that lead to quadratic equation. So this is an example of it. So let's quickly solve our quadratic equation. Of course, you know, we are going to multiply the coefficient of y squared by the constant, which is 20. And that we have that's minus 20y squared. So the next thing we are going to do is to look for the factors of minus 20, that when we add or subtract, it gives us, when we multiply, it gives us minus 20. When we add or subtract, it gives us minus 1. So what are the factors of 20? That's 5 times 4. 5 times 4. So if we multiply 5 times 4, gives us positive 20. Now, of course, our multiplication is minus 20. So first, we can add y to this, add y to this. So by the time you multiply y times y gives us y squared. 5 times 4 gives us 20. But our multiplication is minus 20. Which implies that either of the two we are going to, either of the two we carry negative. Now, how do we know the one that will carry negative? You come and consider this one that is in between. What is there? Is it positive or negative? As we can see, it's negative. So automatically, our negative is going to be in front of 5. So when you do minus 5y plus 4y, it gives you minus y. Minus 5y times 4y, it gives us minus 20y squared. So Instead of writing this now, we substitute our what we got here. We substitute it instead of writing this minus y. So we now have y squared minus 5y plus 4y minus 20 equal to 0. Now we can now factorize. You factorize these two, you factorize these two. Now what do we mean by factorization? Factorization is just that you look at the two numbers in the bracket, which is common. What is common to the two numbers? And I think that is y. Y is common. This one is y squared. That is 2y. Y times y. So you are going to use what you have here to divide. You are going to use what you have outside the bracket to divide what you have here. So that's going to be y squared divided by y, which is y times y divided by y for the sake. Then y will cancel y for clarity's sake. So it means y. So you write the remaining y inside the bracket minus 5y divided by y. Y will cancel y. Then it means 5. Now, if we choose to use, let's see, indices. So we are going to use y to divide this. So also you use y to divide this because it's common to both sides. We see y here, we see y here. So now we say y squared divided by y. We want to use indices now. We said y squared. We said we pick one out of the two bases. You subtract the power. 2 minus 1. That's y. So that's how we got this. The same thing applicable to this. 5y divided by y. You have 5 common base. Y 1 minus 1. That's 5. Y raised to power 0. Still remember the law of negative index. 8 raised to power 0 is 1. So that's 5 times 1. 5. That's how we got this. Alright. Plus. Look at this. This and this. What is common? 5 is common. So you have 5, you write it outside. I said 5, sorry. 4 is common. You write the 4 outside. 4 divided by 4y means only y. Then 4 divided by 20 divided by 4. 20 divided by 4 gives you 5. So equal to 0. Now, the two numbers outside the bracket, you mark them together, make them become 1. Then you pick one from the two in the bracket. So now you have y plus 4, y minus 5. They all equal to 0. So this, now this one will equal to 0, this one will equal to 0. So now, we say y plus 4, y minus 5 equal to 0. So let's pick, you now say this equal to 0 or this equal to 0. So y plus 4 equal to 0 or y minus 5 equal to 0. So y now will give you minus 4 or y equal to 5. This is the value of y. Mind you, our question did not tell us to find y. Let's go back to the question. Look at the question. We have to find x, not y. So, this is where y comes to play. So, what you do is you substitute for y from this place. So, you now say, recall that 5 raised to power x equal to y. Of course, we cannot use negative. We can't use negative. So, you are going to pick the one with positive. So now you have 5. You now see, substitute for y. Substitute for y in the equation above. So 5 raised to power x gives you y. So 5 raised to power x will give you 5 over 1. 5 raised to power 1. So 5 will cancel 5. X can give us 1. Now, this is it. By the time we substitute, let's confirm if our answer is correct or not. We can confirm. Let's substitute for x. In the question, let's see if our answer will give us 0. 25 raised to power x minus 5 raised to power x minus 20. What will it give us? That's 25 raised to the power of 1 minus 5 raised to the power of 1 minus 20. That will give us 25 minus 5 minus 20 is equal to 0. See from the question, so our answer is correct. I hope you understand that. Now this is the question 2. Of course you understand that this now is the same thing as saying 3 raised to power 2x times 3 raised to power 1. You remember law of multiplicative flow. When you have common base, you add the power. Plus 3 raised to power x times 3 raised to power 2 equal to 12. Let me put times here. I'm very confused. So this now becomes 3 raised to power x raised to power 2 times 3 plus 3 raised to power x times 9 equal to 12. So let's quickly say let 3 raised to power x equal to n. So this becomes n squared times 3 plus m times 9 equals to 12. This is 3m squared now plus 9 times n plus 9n equal to 12. Bring it in. Now bringing this constant inside. So that will be 3m squared plus 9n minus 12 equal to 0. And this is the quadratic equation. As we did to the other one, now we say coefficient of n squared multiplied by 12. So that will give us minus 36m squared. So 3m squared multiplied by minus 12. This is what it gives us. Now, let's look for the factor of 36 that when we add or subtract, it will give us plus 9m. The factor of 36 that when you add or subtract, this was 9. So how do you do that? Let's not give ourselves much problem. This is 2. This is 1, 8, 2, 9, 3, 3, 3, 1. So let's begin to match until we get two factors that will give us 9 when we have. No, okay. Let's see. This and this, that's 6 times 6. Right now we have 6 times 6 gives us 36. When you add it, it gives us 12. So it's not 6 times 6. So let's use, this is 2 times 2, 4 times 3. That's 12. Oh, yes, 12 times 3. 12 times 3 will give us 36. Now let's subtract. If you subtract 3, 12 minus 3 will give us 9. Good. Give us 9. So this is how we are going to do it. So it means what we need now, you've been able to get what we need. 12 and 3. We put m here, we put m here. And when you see this is positive 9. So of course, minus 3 we have minus. So by the time you subtract, we have positive 9. Did you get that? Good. If that is understood, let's quickly go through. So instead of writing 9m now, we substitute this. So that's 3m squared plus 12m minus 3m minus 12 equal to 0. So let's factorize this and this. What's common? 3m is common. Then you are left with m plus 4. Of course, you know, m cancel one of the m, 3 cancel 3, remain 1 m. 3 cancel 12, remaining 4, m divided by m. So that's that about that. Now, the second one, minus is here, minus is here. So since minus is common, you put minus. 3 is common, you put 3. So you are left with m. Minus and minus becomes plus 4. Mind you, the two numbers in the bracket must be the same. This and this must be the same. Yeah, so you must ensure that the figures inside the two brackets are the same. So that is why you can pick one. If the figures are not the same, then you are wrong. So make sure that your figures in the bracket must be the same. Not that you have 4 minus m minus 4, m plus 4. You can't pick one. It's not done that way. If you do it like that, you will be wrong. So it must be the same. M plus 4, m plus 4. So now you pick the two outside the bracket. 3m minus 3. Then you pick one of the two in the bracket. M plus 4 equal to 0. This equal to 0. This also equal to 0. This equal to 0. This also equal to 0. So you have 3m minus 3 equal to 0 or m plus 4 equal to 0. So you have 3m now equal to 3 or m equal to minus 4. So m will give us 3, we have to start by 3, then you have this. M now will give us 1 or m equal to minus 4. Don't forget I told you that we don't reckon with minus when we are taking exponential function. We don't reckon with minus, we only use the positive one. Now, don't forget, we said 3m, 3x, 3x power x equal to m. So that's where we are going to now. We say but 3 raised power x equal to m. So therefore, 3 raised power m x now will give you what? What's our m? Substitute 1. So 3 raised power x now you have 3 raised power x will give you 3 raised power what? 0. Do we get that? Now 3 will cancel 3. X now will give you 0. I said we don't reckon with negative when we are doing the exponential function. So recall that that was where m came to the picture. So we want to return m. Now we have gotten our m to be 1. So you have this 3 raised power x equals m. Then 3 raised power x, m is now 1. If we remember the law of negative zero index, law of negative zero index, which says anything raised to power of 0 is equal to 1. So that's why we say 3 raised power 0 is equal to 1. 3 raised power x then. That means cancel 3 cancel 3, so x equal to 0. So we are going to do here. This is 2 raised power x times 2 raised power 1 minus 5 into 2 minus 5 into 2 raised power x plus 6 equal to 0. So we say let 2 raised power x equal to k. How? As we did in the last time. So this becomes k times 2 minus 5 into k plus 6 equals 0. K times 2 you have 2k, 5 times k you have 5k plus 6 equals 0. So subtract this. You have minus 3k, 2k minus 5k will give us minus 3k. Please be conscious of this. Many people will just write 2k and they will 3k, they just miss it because of the sign. Please be conscious of this. Plus 6 equal to 0. So make this cross to the other side. So 6 now will give you 3k. Divide both sides by 3. So k now, k will give us 2. That's our k. Never forget that k is not in our question. We need x, so we substitute. So we have 2 raised power x now, but 2 raised power x equal to k. So you now have 2 raised power x will give you what's now k? 2. So 2 over 1, 2 can cancel 2, then your x will give you 1.